complex numbers, if you don't remember what complex numbers are, you have complex numbers which can become real numbers, and then the real number system is split into what's known as rational and irrational. But a complex number is in the form of A plus BI. That's usually your standard form. And notice how I did my I. It's like a scripty I, okay? This is your standard form for complex numbers. Okay, so everything can be actually written as A plus an I. This right here is the real part, and that right there is the imaginary part. Okay, so I could have like our number 10. How do you think you would write the number 10 in a complex way? You would write 10 plus, what would be your B? 0. 0i. 10 plus 0i. That's what. You know, square roots, by the way, everybody always gets confused. Square roots they think are imaginary. They're not. Square roots are real. Okay. Now, where did this come up? I don't know. I didn't make it up. Okay. No. Well, it came up from the problem. The mathematicians had problems taking square roots of -4, right? What does your calculator say when you take square root of -4? Error. Okay, it can't do it. But we know what the square root of -4 is because we've had Algebra 2 honors. What is the square root of -4? 2i. Where did that I come up from? Because that is the imaginary unit. The imaginary unit is I, and I is equivalent to the square root of -1. And they did it to just make it a little bit more simpler, like mathematics-wise for us, okay? And I do need you to know these special ones. I, obviously, which is square root of -1, I squared. So what's the square root of -1 times the square root of -1? It would be -1. I cubed would then be -1 times that guy, which is just, we call it -I. And then I to the 4th is my favorite one. It's 1. These are the ones that you give as answers. You never give me this. Don't give me I cubed. That's not an answer. -I is the answer. Okay? Don't give me square root -1. No, give me I. Okay? So these 4 right here are the ones. I, -1, -I, 1. Those are the answers I want. So part of your homework tonight will say the following. Simplify. And I to the 53, and then I to the -19. I to the 53, Mrs. Seti, you stopped at 4. I know, but what would happen? What do you think I to the 5th goes back to being? To this one, right? And then I to the 6, I to the 7, I to the 8, I to the 9, I to the 10. It just repeats itself constantly. Well, how can we figure out 53 without having to do this 53 times? Well, the way that I do it, and you might have a different way, but the best way to do it is for every 4 i's, that becomes what? 1. So I want to find out, I want to cancel out all the 4 i's, and whatever remains, whatever the remainder is one of these. So let me give you, so I'm going to take 4, and I got to do it by longhand. You know, oh man, we're going back to 6th grade math? Yes. 4 into 53. 1, 13, 4 into 13 goes 3 times 12. Remainder what? 1. That means I had 13 groups of I to the 4, and remainder 1. That is your I. That is the power of the answer of your new I. And I to the 1, you're done. I mean, that's the answer. That's one of these choices right here. If it was I to the 3, I would write -I. Okay, wasn't that cool? Easy. Yeah, thank you. Thank you for patronizing me. I appreciate it. All right, let's do this one. I have the negative 19. So elevator pass. How do I write this? 1 over I to the what? Positive 19. See, he's in the top right now. If you put this over 1, he's in the top. He needs to go to the bottom. All right. Now you do the same exact thing. Divide 4 into that 19. Oh, that's 4 times 4, 16. Remainder 3. So really, this is really 1 over I to the third. But we don't write I to the third. What do we write?
1 over
negative I. Okay. But sadly enough, you would think, oh, I'm done. No. Here's why. In mathematics, we don't like radicals in the bottom and i's in the bottom. We don't like that. So we want to get it out. And it's very easy to get out. All you have to do is multiply the top and bottom by I. Here's why. Here's what will happen. So what's 1 times I? I. What's I times I? I what? I squared. And what is I squared? Negative what? So really the bottom would be negative I squared, which is I over, this is really negative 1 times negative, which is, the answer is I. That's the answer. Okay. If that was confusing to you, again, if you got like this far, that's pretty good. I give you partial credit there, or even here. You just have to remember to get I's out of the bottom. Okay. They're not for us. All right. And you can handle it. Okay. So what do you think you're going to do here? Like when you're adding complex numbers, you would add what? What would you add with the 5? Because isn't this the real part, right?
Yeah.
This was the imaginary part. So 5 with the 14, there's a minus here though. So what I do with my minus is I distribute it. So I go change it to a plus and then distribute a negative and distribute it. So that way everything is a plus now. But 5 and negative 14, what does that become? Negative 9, okay? And then now put your imaginaries with your imaginary. What's a negative 3i and a positive 6i make? 3i, done. That's it. You'll have questions like this. Easy. All right. But now what do I do if I change it to multiplication? Well, you just FOIL. That's all you have to do. You FOIL it. Because it's a binomial and a binomial. So 2 times 7, 14. 2 and negative 4i, negative 8i. Negative 3i and 7, negative 21i. Negative 3i and negative 4i. Let's be careful here. Negative 3 times negative 4 is what? 12. What was I times I? What did we just say?
I squared.
And what is I squared?
Negative 1.
So let's call this instead
12.
negative 12. So now let's clean this up. And again, write it in standard form. You always want your real part first and then your imaginary at the end. So 14 and the negative 12 are the reals. So they would become a 2. And then this would become 29i. Negative minus 29. Was that hard? You remember this? Is it kind of coming back? It's like x's. It's like you would do with x's. Okay. Third part, rationalize the denominator. Okay. Okay, so again, going back to what I said before, you are not allowed i's in a denominator. It's just, I don't know why they make these rules. I didn't make them up, okay? We just don't like i's in the denominator. If I just had a 2i in the denominator, I would just multiply the top and bottom by I, and that would get rid of it. But if I have a binomial, or pluses and minuses of stuff, then I have to multiply by what's called the conjugate. The conjugate of an a plus bi would be a minus bi. It's just, all it is the sign in the middle changes. That's it. If I gave you a minus bi, then the conjugate would be a plus bi. Are you all kind of with me on this? So what would be the conjugate of 1 minus 2i? What would be the conjugate? 1 plus 2i. So you are going to multiply the bottom by 1 plus 2i and the top by 1 plus 2i. And what do? We FOIL, okay? So the top becomes 5. Let's see if I can save some time here. This is a 10i minus 3i is 7i. Negative 3 times is 6i squared, negative 6i squared, which is really what though? What does that I squared really mean?
-1.
So -1 and -6 make it?
6.
Okay. So my top number is 11 plus 7i. Agreed? Okay. The bottom is actually an easier. You don't actually have to FOIL. Whenever you multiply by a conjugate, the O and the I go away. The outside and the inside become opposites. So you just have to FLA. I'm trying to make an Amy Davisism. It's not working. But FLA. First and last. That's all you have to do. First times first is 1. Last times last. -2 and +2 is -4i squared. But that's really what?
Positive 4.
+4, which is 5 on the bottom. Now, don't write it like this. Write it like this. The real part would be 11/5. The imaginary part would be what? How would you write that? 7/5 I. And that's your answer. Okay? But let's say you ended up with this. You set it equal to 0. And it's just an x squared. If there was a trinomial here, you would have to factor it or something like that. But if it's just two numbers, you can do 5x squared equals -25, right? Divide by 5. X squared equals -5. How do you undo a squared? Square root. Good job. And this is what a lot of people forget. Please don't forget this. I will mark you off on a quiz. When you take a square root or a 4th root or a 6th root or an 8th root, you actually have two answers in front, plus or minus, always, okay? How do you write the square root of -5 with i's? What would you pull out? If you have a negative, you pull out, you just pull out an I, okay? So you would have an I root 5. It's kind of like that I becomes the negative that you pull out, okay? If this was -25, then you could actually write it as what? 5i, plus or minus 5i, okay? So try this one real quick. X equals, what do I always have to write here?
Plus or minus
And what's the square root of 16?
4.
And what's the square root of negative? I, 4i, plus or minus 4i. Was that hard? Right? You can do that. Should remember it. All right, my last one, which is really my favorite one. And we're done. Find the values of x and y. Okay, so this looks really complicated because you're like, ugh, I don't even know how to solve. We never solved radical or equations. It's really not that bad. Okay. If I am an equation, that means my left side is equal to my right side. Agreed? And in imaginary numbers, you have a real part and you have an imaginary part, correct? So the 5x doesn't contain an I. Agreed? So then this must be equal, according to this, to the real part over here. What's the real part over here? So if 5x equals 5, what's x equal?
1.
Done. X must be 1. So then what could you say about then this one? What does 3iy, what must that equal? Well, that must equal the imaginary part. 3iy equals -6i. Divide by 3i. The i's cancel. What's -6 divided by 3? Done. That's how hard that question will be. You'll have one like that for homework, though. Okay, that's it. And your